Hi. So we've looked at a number of types of plots now. We've looked at frequency plots or density plots. We've looked at relationships between numeric variables, relationships between a numeric variable and a categorical variable. But every one of those plots has an issue. They're all fixed to a two-dimensional surface. In front of me here I have a computer, just like you probably do, and it has a two-dimensional projection. And so how do we get past that? And one way to do that is to use what we call plot aesthetics. And we're going to go through 3 plot aesthetics in this demo, which are ones that, and I'm going to go in order that they're known to be best to least best for human perception with these 3 aesthetics. And so that allows us to add additional dimensions to our two-dimensional plot surface here. So I have some code on my screen here that will create our first plot with aesthetics. And the aesthetic we're going to use here is shape. And shape is a very good aesthetic because humans are very sensitive to changes in shape of things. So, and I've specified a list here of 5 different shapes, like the first one is a plus, then a circle, etc. And notice I'm using fairly distinctive shapes, and that's very important. If I had 20 or 30 shapes, they'd all start to look the same, or many would look similar, and neither me nor anybody in my audience would be able to tell it apart. So don't go overboard with these aesthetics like shape. Just use a small number. In this case, I have this what I call shape call, underbar call, and it's fuel type. Now there's only 2 fuel types, so I'm only going to use the first 2 shapes, but I could use all 5 for some other categorical variable if I wanted to with this same plot function. And so what does this plot function do? So it just loops over a list of columns, so I've got these 4 numeric columns, and then I set up a grid using Seaborn, so I get a Seaborn SNS object. And then I'm going to loop over each unique category of this categorical variable, okay, which is just 2 in this case. But for each of those, I'm going to, for each category of the categorical variable, I'm going to create a temporary data frame that I can then plot, okay? See my data is temp here. And I'm just going to do an XY scatter plot. But I'm going to set the marker to whichever shape I'm at in the list. Okay, let's see I got I from the enumerate. Let me just point out 2 other things about this. There's this scatter underbar KWS argument to a lot of the Seaborn plots. And what that is, you can specify a dictionary of arguments you want to pass down to the underlying matplotlib. Like in this case, alpha, regplot doesn't know about alpha, which is the way we control transparency, and I'm using a fairly high transparency value here. But I can say alpha as my key, and then alpha, which is the value that I can pass to matplotlib. And I'm also not going to plot the regression plots on this. I could do that, but I'm not going to, so I just set that to false. And the rest of this should be familiar by now. I'm just making sure I have proper access labels and a proper title and all that. And so let me run this code, and you'll see what happens. So gas cars are in the pluses, and diesel cars are in the circles. So we can see that, for example, some of these very expensive for their weight cars are gas cars. In fact, most of these outlier cars are gas cars. But you can see diesel cars, they're sort of interspersed, but they're mostly out in this area here and a few down there. So that's kind of interesting in terms of weight versus price. Similar story with engine size. All our really big engine cars, especially all these ones that seem to be way off the trend, are gas cars. But we also have some tiny engine gas cars, and the diesels are all kind of in that mid-range. and et cetera. And you can see with city miles per gallon, I'm just going to skip to the end here. You see this, remember there was this group here, and they're almost all gas cars. And the ones that were lying above it, remember I said there were cars that seemed expensive for their fuel economy. Well, they're all the diesel cars. And then our high fuel efficiency cars, there's 2 gas cars and a diesel car. And this clump of cars, which are all low fuel efficiency, expensive cars, they're all gasoline cars. So we've learned a lot, and we've got 3 dimensions plotted on this 2-dimensional surface, which is price, city miles per gallon, and fuel type. So what's another aesthetic we can use is marker size, and generally people are pretty good at sizes and lengths, telling them apart. So a lot of this code is similar to what you saw before. So we have shapes, and I'm going to use as a size column now. For size, generally you'll use either a numeric variable, or you could use a categorical variable that might have some natural order to it. And I have to scale, so I have this size multiplier argument. So I have to scale this so that the sizes aren't like so big that everything's overlapping each other. And there's also another trick. Well, there's 2 really. So remember I said that we pass arguments to matplotlib through this dictionary, but now size, which is S, is the argument name, and it has to be passed through that dictionary. But I also, I actually want the width of the marker. I want its like vertical or horizontal extent, not its area, to be proportional to the curb weight of the car, okay? So I'm going to square it, but then I also have to multiply it by, as I said, by this multiplier so that it comes out right. And the rest of this code is the same as what you saw before. So I'm going to run this. All right, now we have a plot with 4 dimensions on it because we have gas and diesel, and we have marker size. And you can see these large engine cars are quite heavy. Probably explains why they need big engines. These small engine cars are all quite light. See the difference in this little marker here versus a big marker out here. And the diesel cars, at least on this plot, it's hard to see much of a trend here. And again, with horsepower, the diesel cars all tend to be lower horsepower, but you get a wide range of weights of the cars, but high horsepower gas cars are heavy. See, they have large markers compared to these guys. The diesel, it's a little harder to tell. And it's a similar story with city miles per gallon. You get some small diesel cars, some small diesel engines, and occasionally some low curb weight cars that have relatively high prices and lower fuel efficiency. And here's one with a fairly heavy diesel car that's relatively low price and has pretty good fuel efficiency. So there's something else going on here. And that's something you need to investigate. Oh, and also, again, this group of cars are very heavy, low fuel efficiency, high price cars, and they're all gas cars. So color. All right, so color is the aesthetic most people think about, but as we've discussed, it's one that's a little harder for a lot of people to tell apart. And I've also I've created a list, just like I did for the shapes, of colors, and I've tried to use colors that are fairly distinctive, and keeping in mind that a fair number of people are red-green colorblind, so I don't use any specifically red. Magenta is a little close to red, but so I go green, blue, orange, magenta, gray. And for my color column, I'm going to use aspiration, which only has 2 categories, so we're just going to use green versus blue. And now I've added, it's a very similar to recipe to what I was doing with the shapes, but I've added a second loop here where I enumerate over unique colors and create a temporary data frame, and again, plot it using the reg plot. So I plot that again with the regplot function. And again, like the dictionary is the same as we had before, because we're using transparency and we're using marker size. And colors is a direct argument to regplot, so that's right there. And let me just run that for you. So now our legend is a little more complicated. We have gas and standard is green, gas and turbo is blue, cross, and then diesel and standard is green, and diesel and turbo is blue. So basically, standard cars are shown in green, turbo cars are shown in blue, gas cars with the plus or the cross, and diesel cars in circles. So now we start to see the diesel turbo cars that mostly dominate, and then this group down here were the diesel standard cars. Okay, so we're starting to see some differences here, and it's hard to actually see the gas turbo cars. Some of them are overlapping, but you can see they're kind of in this group here. It's more obvious with horsepower, for example, where you can see the gas and turbo cars have higher horsepower for the price generally. And finally, with city miles per gallon, it starts to become clear. For example, the diesel cars, the turbo diesel cars break out like this. And remember, there was some puzzling behavior with the diesel cars. Well, you start to see the diesel and standard is its own group here. And so that starts to explain. So by now putting 5 dimensions on this plot, so the 5 dimensions being price, city miles per gallon, gas or diesel, standard or turbo, we've actually elucidated quite a lot of this data. We've showed some fairly complicated relationships on a 2D plot. So we've used 3 different plot aesthetics now, which is shape, size, color, to add additional dimensions to our plot. So we were able to create 5-dimensional plots, 2 spatial dimensions, and 3 dimensions projected by aesthetics onto our 2D computer screen. And we were able to see quite a lot more detail in the complex interactions that are going on with this auto price data set.